So my next problem, example 3, is log base 36 of 1/6 equals x. So I'm solving a logarithmic equation, an equation with logarithms. So my first step is to try to get it out of this form so that it's easier to interpret. So I'm going to write that in exponential form. So I take the base of 36 and I bring it down and I bring up x as a power and I take the argument of 1/6 and take it to the other side. So when I do that, I get 36 to the x power equals 1/6. Next, I want to write the equation with the same base, like we did in the first example. If you want to go back and look at example 1 from this section, it's very similar to this step. So 36 can be written as a power of 6, 1/6 can be written as a power of 6. So 36 is 6 squared. Put parentheses around it and raise it to the x power. 1/6 can be written as 6 to the -1 power. So now I have the same base on both sides. I can simplify this a little bit so that I get 6 to the 2x using the power of a power property equals 6 to the -1 power. My third step is to use the fact that we have the same base on both sides, and if that's true, then x must equal y. So I'm using this property again to basically cancel out the bases. Step 4 is to solve. Now we have an equation where we can divide both sides by 2 and get x equals -1/2. Now I want to check for extraneous solutions. So to do that, I'm going to take -1/2 and plug it in up here. Well, now since this is already in log form, I would use your calculator to check this problem. So I'm going to go ahead and check using my calculator and plug in the natural log of 1/6 over the natural log of 36, the change of base formula. So when I plug that into the calculator, I get -0.5, which means that x equals -1/2 is a solution, and I'm done.